let's look at that hill, and let's try and draw it. Try and put some idea in your journal. How tall is that? How long is it? Out the front of the bus is west. So which side of the hill is steep and which side is shallow? There's actually two here out the right window, right? Which side is steep? Is it to the west is steep or is the east is steep?
They're all facing similar ways. They're all going west to east or east to west.
So these rocks that we see in the mountains around us have been buried quite deeply. So all that heat and pressure solidifies the rock. This hasn't been solidified yet. This is recent. And so we want to try and understand what those differences are. At the very top of the hill where you guys are sitting, if we looked at it on an air photo, what would that look like? A fat line. Would it be a straight line? It'd be curved like a snake. Well, that's interesting.
I think it's deposited by water because it's swirly. If it was deposited by ice, it would be like a wall pushing it straight, where water can curve and try to find the easiest path to flow.
My thought is that this is probably an esker. And we already mentioned the snake shape of this ridge, and gravel and sand is what it's made up of.
Boulders are always at the bottom, and as you go higher they're getting finer, so that's a really interesting observation. On top of that, it's made up of sediment. Actually, this same sediment is in a drumlin. It's just not sorted like this. We call this sorting. This is an esker that we're on, by the way.
The older set of Yamnuska's rocks were actually part of that mound's rocks. I forget what it's called. The goat, yeah, or goat. That was actually a chunk of goat, and it was that for probably billions of years. And Yamnuska, the younger rocks, were fairly new during the Cretaceous, when a thrust fault pushed a chunk of goat on top of it.
First thing we do is lay them down. These rocks are 530 million years old, and these are 65 million years old. Then create this thrust, which force all this rock over on top. So we have old rock on top of young rock, and then we erode it and leave this little remnant here. That mountain didn't move all at once. It moves in fits and starts. It took 50 or 60 million years to get from 20 kilometers over there to here. So you can see right there, they're mining out the calcium carbonate, and they're just putting it right in the concrete plant right there. So that place right there is pure 100% calcium carbonate. It doesn't occur very many places in the world. Now if we look out the left, that's an entrance to a mine shaft there. And look at this guy here, there's still so they were mining coal here. There's Canada. So this is about 60 million years ago. There was an exotic terrain, an island arc of volcanic material that was big. So that little guy is being carried on this plate. Little guy, big. So you've got something that's, well, 500-600 kilometers long and maybe 100 kilometers wide, rams into the side of North America, rams into BC, rams into Washington. Bam! Then you start the push. There's Alberta. So we had exposed Canadian Shield over here, and this was actually a great, huge seaway. Where we're standing was covered with water. That's kind of hard to believe, hey? There were no mountains though. The mountains were islands we had off here, but we didn't have any mountains here. So this was a low, big, flat area. It was actually perfect to grow reefs, just like what we see in Belize or what we see on the Great Barrier Reef in Australia. So we are in the Bow Valley right here. Canmore is sitting right here. And remember I pointed out those coal mines as you're coming in? So that's the coal sitting in there. It's actually in a little syncline. They were mining it here and they mined it over here, both sides. That's one of the reasons we like to understand what we call the structural geology. How are the layers structured in the earth? And we know we've got coal here, and we know we've got a syncline. We know we can start looking for coal over here. Back over here is actually one of the better spots on this trail to actually appreciate the shape of the Bow Valley. Anybody find a fossil? Doesn't look like a fossil, does it? So that's the stromatoporoid building up, and it looks like a little bulbous thing that sticks up.